and change this workspace. So today, what we are going to do is we are going to create bit fields. Okay, we are going to create structures and bit field for an embedded code. So I'm going to create a structure for structures with bit fields for this RCC register, and then for the mode registers, and then for the output data register. Okay, so these registers are useful for triggering the GPIO, to enable or to disable the GPIO, to select the modes. Okay, so I'm going to use the same code, but we are going to use structures and bit fields for creating the project. Let me create a new project file, new STM32 project. Okay, so I'll also open the data sheet. Okay, so in this data sheet, like I just repeat, like you just go for the memory map. You should be aware of this memory map because all peripherals like UART, is SPI and I2C or the GPIO is connected via a bus to the ALU unit. Okay, so this bus, you have to enable this bus because all peripherals need clock. So you have to enable this bus, and first you should know the name of the bus, to which peripheral is connected to which bus. For that, like you need to go through this memory map. So this memory map will have a address for the bus, so that you could use this address to access those peripherals. It will have the base address and the ending address. Okay, so by using this base address, you could access this peripheral, and the bus column will give you like what bus it has been connected. Okay, so you should be aware of this. For example, GPIO, it is connected to this address. Okay, it is connected to AHB1. It is connected to AHB1, and it is the starting address. It is a base address. Okay, it is a base address. If you want to access any of the registers of GPIO, then you could access those registers in this address. Okay, you have to go detail into the GPIO register, and you have to add the offset value. Okay, now let's choose the board. Nuclear 411RE. Okay, click this, click next. Okay, example 1. Click empty, click finish. Okay. So okay, so you in the source file, like you have main.c. So first I'm going to increase the font size. Appearance, click appearance, colors and fonts, C++. Okay, editor, click editor and click. Okay, apply and close. Okay, okay. So first we are going to create a header file. So I'm going to file, I go for new, I just create a header file here, main.h. Okay, and click finish. Okay, click finish. So these are the include gods, like you have to write in between this. Okay, you have to write. So I just type hash include stdin.h. Okay, So let us create a structure. Structure for RCC. Let us create a structure for the RCC register. First, I will open the data sheet. Okay. So we have to so we have to create all these member elements. Okay. So totally there are 32 bits. So GPIO A and GPIO B, these are all the member elements. And reserved and CRCN reserved, these are all the member elements. So I'm going to create a structure with those member elements. Okay. So uint 32T GPIO A EN. Okay. EN, and it is 1 bit. Okay. It is 1 bit. It is 1 bit. Whereas here it is reserved for it is 3 bits. So GPIO A to GPIO E. So what I will do is I just copy this and paste, and this is GPIO B, this is C, okay, C, and this is D, and this is E, F, G, H, E. Okay. H and I. Let me check one more time. GPIO, okay. And then reserve. We have reserved. So just copy this. Reserved. This is reserved because we have reserved like lot of reserved are there, but these member elements you should have a unique name. So reserved, it's 3 bits. CRCN is 1 bit, and reserved is 3 bits again. Okay, and reserved is 2 bits again. So I just copy reserved as I just make it as reserved as 3 bits, and CRCE is 1 bit, and again reserved 2. This is 2. It is again 3 bits. Okay. Again we have reserved. It is 2 bits. Okay. It is 2 bits here. So we are creating the member elements. We are creating this as a member element. So reserve, and BKBSR, okay, BKB SRAM. Okay. So reserve 2. Reserve 3 we have, reserve 2 is, reserve 3 is 2 bits. Okay, reserve 3 is 2 bits. Here it is BKBR, BKB SRAM, BKB SRAM EN, and it is 1 bit. And then we have reserved, I think it's reserved 4. Reserved 4 is 2 bits. Okay, sorry, it is 1 bit. Okay, it is 1 bit. It is 1 bit. CCM data is also 1 bit. DMA1 is also 1 bit. So I'll just so 4 is 1 bit, and CCM DAT underscore EN is 1 bit. DMA1. Okay, DMA1 EN is 1 bit, and again DMA, it is 2 underscore EN, it's also 1 bit, and then reserved 5, it's 2 bits. Okay, 2 bits. Let me cross check once. It's 2 bits. Okay, and then we have Ethernet MAC, enable TX RX. Okay, TX RX TP. MAC underscore EN is 1 bit. TX sorry, it is TX is 1 and we have RX, okay, and TP we have OTGHS and OTG, that's for USB, OTG, okay, OTG, so OTG, H, here, okay. So let me save this program, right click and build the project. Okay, it's 0 error. Before this, I need to include this file, else hash include. It's main. It's, you have to mention that in double quotes. Right click, build project. Okay. So right click, build project. Okay, so we have to give a name like RCC AHB1EN underscore T. Okay, so we have created this structure for this. Let us create one more structure for the mode registers. Okay, so let us create the structure for the mode registers. Okay. For the mode register, so mode R to mode 0, mode R, so totally it is 16. Okay, totally it is 16, like mode R, okay, mode 0, mode R 0 to mode R 50 we have. So let us create this one. Okay, so uint 32T, it's 2, it's mode 0, mode 0 is 2. Okay, let me check. I just click, go for GPIO, GPIO registers. Okay, so let us keep as mode R0 to mode R15. Okay, so this I'll keep as mode R0. Okay, mode R0 to mode R50. Okay. Okay, so this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, okay, 12, 13, 14 and 15. Okay, 14 and 15, 14 and 15, and it should be terminated with the semicolon. Okay, so we have created the mode R register. Let us give the name for this. I will take underscore T. Okay, mode R underscore T. So let us create, let me cross verify, like build the project and check whether there is any error. There's no error. Let us create. So we are creating structure with bit fields. So when you give this bit field, it will allocate only 32 bits. Okay, if you check the size of the structure, we have in yesterday example, we have calculated the size of the struct. When you use bit fields, the size is only 4 bytes. Okay, when you if you without using this bit fields, if you use structures, then that size will be more. So in embedded, like you have to reduce, whenever you deal with an embedded system, you have to reduce this memory, because we are dealing with the limited memory. So you have to reduce the size. Okay, you have to optimize the code. Now let's create one more structure for the output data register. Okay, so let us go for the data sheet. So data sheet, on the GPIO registers, you check for the output data register, ODR. Okay, similarly you can create for input data registers and everything. So today, like I'll create the output data register. Okay, so this is the output data register. So we have 0 ODR 0 to ODR 15, and 16 to 31 is reserved. Okay, so these are all the member elements. So ODR 0, ODR 1, ODR 2, these are all the member elements I'm going to create. So I just copy this one. Okay, so unit 30, like I just create. Let me check for the ODR 0. Okay, it is ODR. Okay, and it is 1 bit. ODR, the width is 1 bit. Okay, 1 bit. Copy this, paste this. Okay, so ODR 1, 2, 3, and it's 4, 5, 6, 7, 8, 9, 10, and this is 11, and this is 12, and this is 13. Okay, 14 and 15. So we have created 15 plus 1. Okay, so that is reserved 16. Okay, reserved is 16. So we don't want that one, so it will allocate the bit. So if you want, you could leave it off. Okay, so I just create that is reserved as 16, and let me use the same name here. Okay, ODR underscore T. Okay, sorry, underscore T. Save this one, right click, build the project. Let me check for the error. There is no error. Okay, so we have created this. Let me check. Okay, so let's go for main.c, and you have to declare the variables for this. Okay, so you have to declare the pointer variable here. Like I'll just go for the, I just copy this. Okay, so this is the pointer variable, like ahb1 enr. Okay, this is the variable name, pointer variable name, and the address is ahb1 enr. Like just go for Windows, show view, SFRs. So you have to load that. So I will use the address from the yesterday class, like it is 4002 is 0x400 23830. Okay, and you have to typecast it. How to typecast. Okay, let me check one more time. Just give me a moment. So right click, build the project, and right click, go for debug as. Okay, so let me check the first SFR registers. I just load this program. Before that, I need to connect the hardware. Just give me a moment. I'm connecting the hardware. And I have connected the hardware now. So if I right click and debug as STM32. Okay. Switch. So I'm just downloading to the hardware. You could do it on two ways. Either you can get the address from here or from the data sheet. Okay. So I use RCC, like click RCC. These are the address. Okay. I just verify once. It is 0x4002238038 AH address of the AHB1 ENR, okay, 3830. Okay, and then we need GPIO, the address of the GPIO. Okay, so let me check the address for the GPIO. It should be on GPIO, this ABC. Okay, for GPIO. Okay, for A. So this, let me create this as GPIO, like GPIO A. Okay, GPIO A, and this is the address for the mode register. So I just type GPIO A mode R. Okay, I have just for remembering it easily, so I just keep GPIO A _ mode R 04 0x4002 and 0. Okay, I'm just taking this address from here. If you want GPIO C, okay, I'll also take GPIO C. You need to mention here mode R, but as of now I just comment this line, but I'll copy this. I will execute GPIO mode C. Okay, let us check GPIO mode C first. Mode A after that, GPIO C _ mode R. The address is this 208, okay, 00. Okay, then the output data register. You have to configure the output data. You have to typecast this one. Have to typecast. Okay, typecast. Then you need to take this GPIO X ODR T. So declare GPIO C ODR. Okay, GPIO C ODR equals, this is the word 0814 is the address. Okay, copy this. 0814 is the address. Here you could see here. Okay, and you have to typecast. Copy this and you have to typecast it. Okay, so we have created this now. Then the next thing is to blink the LED. Okay, to blink the LED. So to access the member elements. So the first thing is to enable the RCC. So we have to enable the RCC here. First thing is to enable RCC. Let me check. This is to enable. So to enable, dereference this one, GPIO, I'm going to use C. Okay, C enable, choose this equals 1. I have enabled this one, and let me enable this, enable the mode. I have to configure the mode. So the mode, in the mode register, we need to enable 01, 01, 01, 01, 01, 01, 01 to mode R0 to mode R7, because we have connected 8 LEDs. Okay, so we need to enable all those things. So let us enable the first. Let us enable 1, and then we will check. So enable this mode R0. Okay, equals 1. Okay, equals 1. It's for the, this is to configure as output mode. Okay, this is output mode. You have to store 01. Okay, so 01. So this is 01. This is to enable clock. Enable clock for GPIO-C. Okay. Now so we have enabled this mode. Now we have to enable this ODR. Okay, ODR. So this is, I'm just enabling the first bit, equals 1. Okay. So I will put it in a while loop, while of 1. Okay. Zero. Okay. So we have created a delay. So I just go for the top, and I created a delay void, delay of void for, okay, for U132 underscore T of T equals I less than I plus plus. Okay. So save this program. Let us check. Now. We have implemented as a structures. I stop this one, terminate this program. Right click. Let me build the project and check for an error. We have 3 errors. We have not initialized equals 0 here. Okay. Right click, build the project. Sorry. Okay. So debug us. So let me check now. Let me check this application. Let us keep some breakpoints. Switch. Okay. I'll switch to the hardware. So this is the hardware which I have. Okay. I have connected this LED to port C. So we have enabled only one now. Okay, we have enabled only one now. Let me go for step-by-step execution. Okay, and you could check the appropriate registers now in AHB1 ENR. You just click the RCC register here and check AHB1 ENR and check whether it is selected. GP, we have selected GPIO C. Okay, you have to AHB1, it is AHB1 ENR. Okay, so GPIO C, it should be selected. Okay. AHB1 ENR. It is 04023830. So if you check this, like it should be selected here. Let me check now. Let us go step by step execution. 830. So if you check this, like it should be selected here. Let me check now. Let us go step by step execution. Okay, it should select G. Now, if you on the right hand side, you could see that GPIO-C has been enabled now. I have enabled this GPIO-C. Okay. Now you need to enable the mode or registers. It will be on the GPIO of C, the mode or registers. Here we have to set the last 0, 1, 2, 3, 4, 5, 6, 7, all this 0, 1, 0, 1, 0, 1. Okay, but now as of now we have toggle only mode or 0 here, 0, 1. So let us check this one. It's set now. Next is ODR registers. We have toggle this one as 1. So only one LED will glow. Okay. If you check on the on this, like you could see the LED is one LED is glowing now. Delay. Okay. So I just give continue and like it's blinking now. Okay. If I want to select all the 8 LEDs, okay, if I want to select all the 8 LEDs, then you have to enable the mode for mode. Currently we have enabled only the one like okay. So it has to be enabled for all the 8. Mode 0, mode 1, 2, 3, 4, 5, 6, okay, 7 and 8. Okay, 7 and 8. And for this, you need to enable like copy. Okay, you can copy. This is 1, this is 2, 3, 4, 5, 6, 7, and 7 and 8. Okay. Seven and 8. Right click, build the project. Okay. Now debug as STM32 Cortex M C++ application. Okay. I flash this code now. Switch for the debug perspective, and I resume the button. I press resume button. You could see all the LEDs toggling now. And if you want to give it as a, instead of this, like if you want to give it as a bus, then that is also possible. All you have to do is you just terminate this program. Okay. Terminate this program, like you go for main.h. In this main.h, like I'm going to give it as a bus now. Okay. So I put this is underscore 8. It is totally of 8. Okay. So I can comment this line now. Okay. So I can use it as a, I could directly give the value there. Let me show that output. Okay, to 7. Okay, similarly for mode, let us check for the, I'll do it for this LED. Let the mode be, let the mode be separate. I just go for main.c. So instead of this, like I comment all this line, okay. Okay. So when you type, it will show this. Right click. Let me build the project once. I'll just build the project once. Okay. Okay. I will build the project once. Build the project. Okay. And if I type now, okay, if I type this, it will show. Okay, it should show. Actually, we're not in the C++ perspective. Let me check for the C++. Okay. Okay, just go for the main.h and check this is ODR. Okay. Okay. So I just give ff here. Okay. So ff. And here it is 0, 0. Okay. Right click. Okay. Okay. So right click and build the project. Right click, clean the project first and build the project. Okay. Debug us. Okay, switch. Resume. So you could see the output is blinking now for this. Okay. So if I want to give the alternate, like 1 0 1 0 1 0 1 0, it's a okay. Terminate this. Right click, build the project and debug as STM32 application. Okay. Switch and resume. Okay. So if I want to enable the port, if that the advantage of the structure is you could reuse this for the other port also. Okay. For example, I want to enable for the port A, the LED for port A, then just copy this. Okay. Just copy and you just type this. It will show this GPIO A to enable GPIO A. Okay. So I have enabled this one. Okay. To enable the GPIO mode of A, then you have to give the address of this here. Okay. So the address already we have given for mode T. Okay. And for the ODR T also, like I just copy this GPIO ODR. This is A. Okay. For this is A. And we need to give the address for this. Okay. So window, like let me search for the address here. Build the project. I load the project and will check for the address. Else you could also get from the data sheet. There are two ways you could do this. Okay. I just click for the registers here. I click for This mode R is there. It's GPIO A for ODR. Okay, for ODR it is okay. For ODR GPIO A it is 40414. Okay, it is 0414. Okay, 040020020014. So that is the address. Okay, now terminate this and mode, we have to set mode for GPIO A. Okay, so GPIO A mode, or it is connected to PF. I'm going to use the use this LED. Okay, use this LED on the board, which is connected to PA5. Okay, PA5. So we need to enable this mode 5. I have to check the data sheet here. Like for mode 5th pin, it comes here 01. We have to set 01 here for the mode or 5. So mode or 5 we need to enable. Okay, I have enabled mode or 5, and ODR, like I'm going to use the same ODR. Okay, it will enable other pin also. As of now, I just give, but you have to correctly give the value for that. Okay, right click, build project, and click debug as STM32 C++ application. Switch. Okay, and run the program. Okay, so you could see the LED on the board is also blinking now. Okay, but it is not off. It is only blinking, like it is not blinking actually, but it is on. Now to off this, we need to use we have given, like here we need to give us 00. Okay, 00. Right click, build the project, and right click, debug as STM32 Cortex M application. Okay, switch and run button. Okay, now if you check, the LED is blinking now. I'm not sure whether it is visible for you. You could see the LED on the board is blinking, like there is an yellow color here. Okay, okay, green color LED which is blinking. So today, like today class, like we have gone through like how to like we have how to use structures and bit fields on the code. Okay, on the embedded C program. I hope it helps today. You have the great learning, like even though if it is a LED blinking code, but the key takeaway from this lecture is how to use bit fields and structures for the embedded